Hello, it's Dr. Bhatt here from Chem. Dr. Bhatt Fields presents a video on organic chemistry reactions, and the topic today is hyperconjugation in crotonaldehyde. So, we find that there are two terms, crotonaldehyde and hyperconjugation. What is crotonaldehyde? As the name itself indicates, it should have an aldehyde group, and it is an aldehyde. Next, we have to understand what is meant by hyperconjugation and what are the products obtained by hyperconjugation of crotonaldehyde. Okay, we are going to take it up today, and crotonaldehyde is nothing but 2-but-2-enol, which is a condensation product, final condensation product of two ethanol molecules containing alpha hydrogen atom. And aldol condensation we have already taken up, and we have discussed about it. And in presence of dilute NaOH, you get 3-hydroxybutanol. The aldol product is obtained here, which in presence of anhydrous HCl, that is hydrogen chloride gas, and a little heat, gets converted to an alkene, but-2-enol, and with the loss of water molecule. Now, this but-2-enol is also known as alpha-beta unsaturated aldehyde, and this alpha-beta unsaturated aldehyde is crotonaldehyde. The common name of but-2-enol in alpha-beta gamma system of nomenclature is crotonaldehyde. Well, there has been a system of nomenclature using alpha, beta, gamma from the carbon atom attached to the functional group. For example, in CHO, this is the functional group. Next atom is alpha, IUPAC, it is number 2, and then beta, and then gamma, and that way. And if you recall, still we are following the same system of nomenclature here for alpha carbon atom in aldehydes, isn't it? Alpha carbon atom is there in an aldehyde. So this crotonaldehyde is a common name of but-2-enol. No confusion. And still, this aldehyde is identified in many terms as crotonaldehyde and has been accepted by IUPAC also. Therefore, now let us see what will be the product obtained by its further reaction with crotonaldehyde and hyperconjugation. Well, this is what we have discussed earlier, and all the details are given here. Now, what is hyperconjugation and what is the final product obtained by the interaction of molecules of crotonaldehyde or but-2-enol in presence of NaOH again. Again, in presence of NaOH, that is sodium hydroxide, a similar reaction occurs as in aldol condensation, and the OH group gets attached to a carbon atom here, which again on dehydration forms a compound which is a condensed product containing 3 alkene groups, and this is the final product. It is abbreviated as CH3, CH double bond CH3 times, and CHO. Final condensation product is obtained through hyperconjugation. Now, of course, this reaction takes place in presence of sodium hydroxide. Now, we need to know what is hyperconjugation. Now, before getting into certain details about hyperconjugation, we need to know, or we have to recall and look back over the configuration, electronic configuration of carbon. We know that in the ground state, electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1. Well, this doesn't represent a tetravalent carbon atom. Well, during the course of a reaction are in the excited state, this turns to 1s2, 2s1, 2px1, 2py1 and 2pz1. Now, in the excited state, carbon is tetravalent. Now, when a double bond is formed here, as in alkenes, we find that there is one sigma bond and one pi bond, which is formed by head-on overlapping. That is, px and px get overlapped, and thereafter one of the carbon atom contains CH3, that is the methyl group or any alkyl group. Then what happens that this methyl group or CH3 group, as known to us, is electron releasing group, and here, as is the case, there are two vacant p orbitals. Two p orbitals are vacant in both the carbon atoms. So, under the situation, in one of the case where the carbon atom is attached to three alkyl groups, that CH bonds, sigma bonds, one of the bond, the electron of one of the bond gets delocalized. There is a delocalization of sigma electrons of one of the three sigma CH bonds of the alkyl or methyl group directly attached to the atom of an unsaturated system. This is when there is a double bond, we call it unsaturated system. And now what happens is that since the electron in one of the CH bonds of the alkyl group gets delocalized, uh, it adjusts itself in the uh, p orbital here, but there is another p orbital of the second carbon atom which is bonded to it, and therefore what happens that there is an alignment of this electron with the other p orbital of the other carbon atom, and they lie on the same plane, and that is known as alignment. And because of this, the electron becomes, this carbon becomes positively charged because the electron, there is a partial electronegative charge over here, and C becomes positively charged. So this is a permanent effect, a hyperconjugation effect. And a few lines are provided here for your reference. You can go through it. And under the situation after hyperconjugation, when there is excess of NaOH, the OH gets attached, similar to what has happened in case of aldol condensation, giving a molecule having three different double bonds or alkene groups, and you get the final condensation product here. So, well, this is the situation of but-to-enol or proton aldehyde when, due to hyperconjugation, a product is formed. I suppose this should be clear to you. Please go through it, and uh, we shall be back again with some more details about certain other topic about aldol condensation or aldehyde, etc. Okay, till then, bye. Thank you.